Okay, this is the video solution for problem number 3 of the midterm given to lab section 54. As you can see, the geometry is described here. It says two pins are symmetrically inserted into this cylindrical specimen, and the two ends of the pins are pulled in opposite direction by 0.0005 inches. Okay? Now, the minute that you see this, you have to understand that this problem needs to be done as an assembly. You have trained your eyes so that you can spot problems that are to be done with assemblies, and solid elements should be used to model this problem. Okay? It is very unlikely that you can actually solve it successfully and correctly with shell elements, but if you did, I'd like to see what it is, what you have done. Now, it says identify all planes of symmetry if they exist. Because of the nature of the problem, you can cut it in with 3 planes, and I'm going to do that. I'm going to make this whole thing, and then I will cut it with 3 planes, halfway in the middle, along the length, and along the width. And you're asked to do local mesh refinement at the 2 holes. Okay, fine. And obviously the most appropriate element of solid elements. Okay, so let's go ahead and make the thing. Let's go here. We start with a product file. File new. Product. And immediately we're going to save this thing. So file, save management, save as, desktop, new folder. And this is midterm, section 54, and it's an assembly. You cannot solve it as a single part, okay? Okay, so insert a new part in there, and I'm going to call this thing the cylinder. Right-click properties, product, I'll call it cylinder, CYL, and CYL. Let's make it. So double click on this on a convenient plane. Obviously on that horizontal plane, I will sketch 2 concentric circles. One like that. And I think the radius of that outer cylinder is 2, and the inner cylinder, outer circle is 2, and the inner circle is 1. Okay, so this is going to be 2, radius 2, diameter 4, and we'll do another circle here. This one is going to be 2, diameter 4, or radius 2, diameter 2 and radius 1. Okay, that's good. Exit. And we're going to pad it. Now, obviously, you have to be in part design to be able to pad. We're going to pad it symmetrically in both directions, and a total height of 12 inches, which means 6 in each direction. There we are. Now, I want to make those holes in there. So on this plane, I will sketch 2 circles and then make a pocket through it. So those 2 circles are, let's say one of them we draw up here. How about this? The diameter of that circle is 1. So let's go ahead and make that. Diameter 1. Okay, and the position of it is 2 inches from the top. So the distance from the center to this line should be 2. Okay, you can make another one down here and pocket it, or you can pocket and then mirror it. It's all up to you. So let's actually do another one here. Let's mirror that circle with respect to this. Okay, that's easy. Exit, and then we pocket symmetrically, and there are our two holes. So let's go up there. Eventually, I'm going to come and cut this thing 3 ways. So it's true. So insert, new part. I'll call it the top pin. Properties. I understand some of you may decide to use an instance of it, etc. So it's easier without too much of a hassle to do it like this. Top pin. Okay. Let's make it. Double click on it. So on that vertical plane, I will sketch. I want to draw a circle like that. Why don't you project that circle? Can I not project that circle? So project that circle. Okay, there we are. Exit and just pat it in both directions. So it's mirror extend, and the length of the pin is total 6 inches. So it goes 3 inches in each direction. This is the top pin, and I repeat it for the bottom pin. That's too extra work, but it's simple enough that we're going to do that to avoid any complication. Right click properties, bottom pin, DOT, pin, and BOT pin. Pin, and let's make it. Double click on it. On that vertical plane, I will sketch, do exactly the same thing. So project that circle. There we are. Exit and pat it symmetrically or mirror extent, 3 inches in each direction, and we say OK. We go all the way to the top. Everything is made out of steel. Yep. Yep. Everything is made out of steel. Metal, steel on the entire assembly. We say OK, and we are done. Save. Now, notice that I did not put any assembly constraints here because I have no plans of moving it. But if you want, you can put assembly constraints. It's not needed as long as you don't have to move these things. So we're going to go to general. Oh, we have to cut it now, right? Split it 3 ways. Let's do this. So the first thing we're going to do, we're going to cut it top and the bottom. It says, well, all of these, well, let's see now. Which ones are these? Which ones we want to be affected? We want cylinder definitely to be affected. Let me try it again. Let's try this. Okay, so cylinder, send it down. I guess let's actually do this. So let's see now. Cylinder, top pin. Okay, bottom pin. It really doesn't matter. Okay, and then again, click on the saw with this plane. All of them. A cylinder, top pin, bottom pin. The bottom pin is gone, but it's okay. So we don't care. And then again with this other plane. So the saw again. This plane, cylinder, top pin, bottom pin, send it down and say OK. So this is all we need. Because of this symmetry, this is all we need. Okay, so save it. You could have created the model exactly like it is. Now, we're going to go to generative structure analysis. CATIA sees two. In this case, because we made the cut, it sees only two solid parts, and it's going to mesh them both. You can see the mesh, right-click mesh visualization. Okay, you can see that. Now you are asked to refine the mesh around the hole. So let's deactivate this plot and select the second toolbar on the left of the tool manager. And it says, which one of these two do you want to refine? Well, I want to refine the one for the cylinder, okay? The one for the cylinder. Mesh around the hole. That's the cylinder. And hide the pin. I want a finer mesh around this. And is this good enough? Yeah, okay, sure. That's good enough. Right click, activate the mesh. And now you're going to see the pin and the hole and a fine mesh around the hole. This thing is fine around the hole, as you can see. We didn't do anything to the elements of the pin. So deactivate this. Let's move on. Where's my pin? There's a pin. Okay. Now, surface slider. Surface slider is down here. This is a plane of symmetry. This is a plane of symmetry. This is a plane of symmetry. You go on this side. Don't forget, this is a plane of symmetry, and that is a plane of symmetry. Any one of these you miss, unfortunately, you're going to lose the marks for that particular part of the problem. I know it's unfortunate, but that's the way it is. Now, as far as pushing this thing up, okay, notice that we don't have the issue of this pin turning here or coming out because there's a surface slider there, there's a surface slider there. It won't be able to rotate. It won't be able to, stick out. So all we do is the user-defined restraint. First, you make this thing 0, going up. Let's uncheck all of these. Make it 0 going up, because then we want to change it to 0.0005. And that is enforced displacement right there. And this is the restraint that we put in. Let me do it from here. This one, you see this? And we want upward 0.0005. Do not divide it by 2, etc. All right, so let's save it. File, save management, analysis, save as, desktop. Is that the right folder? Yeah, midterm 54 assembly. That's good. It is the right folder. And we're going to run this. It's going to work, no problem. Deactivate that. Say yes. It won't work actually, because this is going to go through. This is going to go through that. Cylinder. Something big time we forgot, and that is putting the connections. Now it did run, but we don't know what. Hey, look, it moved through that. Okay, so obviously we missed something about connections. So deactivate this. Okay, so let's create a connection between. First component is the surface of the pin. Second component, you hide it. Surface of the hole. Say okay. And this connection is not fastened. Not fastened, because you bought these and you inserted them in. You didn't put any glue. You didn't weld them together. So this is contact. We have done problems like that. Many, many problems like this. So contact, is this the contact? For this last connection that we made, or the only connection that we made actually, right here, there, this one, right? And notice that it put the contacts icon here. And now we're going to save it and run it again. This time it will not go through that. Okay? It's not supposed to. There we are. Change the scale here. Let's change the scale to default. Okay, good. So if you look at this side, needless to say that it's not going. Now, if you see that it actually doesn't, let me see for a second. If you get the impression that it's actually penetrating that, that's probably because of our elements. We have to, now this would have been fine. There's no issue here. We did make it contact. Yeah. So let me do the following. First of all, let's look at the animation. Where is that? Right here. See, if this happens, it's because of the bad elements. Bad element meaning that you have to use a smaller element or you have to use maybe parabolic one. So let me show you, convince you. So let's change this thing to parabolic and let's convince this thing to parabolic. Oh, now we don't expect you to do that on the test because all your steps have been right, but you should have used a smaller size element or maybe a better type, which is parabolic. And let's see if that will help a little bit this issue. Okay. Let's look at the deformation. Activate it. Yeah, it didn't help that much. Yep. But the process is okay, and we need a finer mesh around the hole. There's no doubt about it. Okay, so this is fine. The procedure is fine. Okay, and yeah, average ISO, material shading. This is fine. This is fine. So you really need the fine mesh in this area so that this does not actually go through it. Okay, notice that it is not penetrating through the entire thing. It's just that at this corner we have a problem. And then you can plot the 1 meter stress. Notice that there's going to be a big stress in this area. In fact, if you say where is the maximum stress, let's figure it out. Probably in this area. So where is this M, big M? This M maximum, probably, yep, right there. We can see that. You need a fine mesh here. We don't have. That's good. This is good for the test. Okay.